Welcome to the geometry section of discrete math. Yeah. Okay, so in this section, this is the last section of chapter 9, we're going to talk about similarity. For figures to be similar, they have to have the same proportions. Okay, so similarity goes back to dilations from Math 2, where you've got a smaller figure and a larger figure. They have the same shape, just not the same size. One might be 2 times as large. One might be 3.5 as large. Okay, they're not always going to be pretty numbers either. So when we set up a proportion here, okay, please make sure if you put A1 from the smaller figure over top of A1, I'm sorry, that's A2, the smaller figure. If you put A2 of the smaller figure over A1 of the larger figure, you need to do the same thing when you set up your second one. So it has to be from the smaller figure on the top, from the larger figure on the bottom. Or another way you can do it, if you do side A from the first figure over side B from the first figure, you need to do A on top and B on bottom from the second figure. Okay, so you need to make sure that the sides that correspond match up as you set up your proportions. So, for instance, if I come over or down here to the rectangle, if I put the width and the length from the figure on the left, what's got to go on top in the second one? The width. Okay, so just be very cautious of where you set everything. One other thing you're going to need to know before we do this. What is the area of a circle?
2 pi r. No.
Pi r squared.
You're thinking circumference.
Oh, never mind.
No, Lewis, you've got it.
Oh, yeah.
Pi r squared is area. 2 pi r is your circumference. Pi r squared is your area. Okay, so just keep that in mind. So that leads us to here.
Wait, what was the rings? I think.
The area?
Oh, like.
Wait, so what was
I
pi
didn't
r
write
squared?
it.
That's the
Circumference area.
circumference.
Pi r, 2 pi r is circumference. Pi r squared is your area. I didn't write anything. You didn't miss it. Okay, so rectangle A. We're going to do everything by rectangle A. If rectangle A is a 5 by 8 rectangle, what is the perimeter?
26.
How did you get 26?
You multiply. I guess you multiply 2 by 5 and 2 by 8 and then add them together.
Good. Remember, if it's a rectangle, you have 2 sides that are worth 5 and 2 sides that are worth 8. It's a rectangle, which gives you a total of 26.
40.
Okay. My area then is 40. 5 times 8. Okay. So I can now go through and get the dimensions for rectangle B. Okay. But I'm going to show you a shortcut. So if rectangle A is a 5 by 8 rectangle, and it tells me rectangle B is 3 times larger, what's the dimensions of rectangle B?
15 by 24.
15 by 24. Okay. 5 times 3 and 8 times 3 makes it a 15 by 24. Okay. Perimeter. My perimeter was 26 here. Well, it's going to be 3 times as large. So 26 times 3 makes this perimeter.
I didn't even think about it.
I got 47.
Huh?
78.
78.
It's like,
Boom.
okay. So that trick works there as well. The trick also works with area, but watch what I do. 26 times 3 squared. Why did I square it?
Because it's two squares.
Because yeah.
It's area. An area is squared. So if I was doing volume, I would multiply it by 3 cubed. Okay, so keep that in mind. So you can still use the same trick. You just need to make sure if you're dealing with area, you square it by it, or if you're doing volume, you cube it. So what's the area?
234.
234? Okay. Finally, rectangle C. Rectangle C is half of the size of rectangle A.
2.5 by 4.
Yeah.
2.5 by 4.
Wait, what did y'all put in y'all calculator? 26 times 3 squared.
26 times 3 squared.
No, 'cause I'm getting a different answer.
You have to put it in parentheses.
I didn't do it. I
Put it
put
in
it in
parentheses.
He said 26.
It shouldn't matter.
Yeah,
he must have been.
He's like 26 times 3 squared. Okay.
Exactly what I put. I didn't put no parentheses.
So, if it's shrinking, what should I do?
26 divided by 2.
Okay, we divide when it shrinks. So, I started with 26 and I'm cutting it in half, which means my perimeter is 13. Okay, the same thing's going to happen with your area. I'm still dividing, but instead of dividing by 2, I'm dividing by
3, 4.
No.
well, technically, yes, 4. But why?
2 squared.
2 squared.
Oh,
Okay? Whatever you're doing, this is area, so don't forget, we have to square it. Okay, so yes, you're technically dividing by 4. Oh, that should be 40. Sorry, not 26. I did this in the last class, too. Dang. 40, because your area was originally 40, divided by 2 squared. So your area is 10. Question. Okay, let's practice. So, I gave you everything over here. If your figure's getting bigger, anytime you're doing anything with lengths, perimeter, dimensions, it's just times K, whatever your scale factor is. Areas times K squared, volume times K cubed. And then if you're shrinking, if you're getting smaller, we need to divide by K squared, or by K cubed. So, for instance, A and B are similar rectangles. The length of B is 2.5 times larger than A. So, what is your small figure here? Is it A or B?
B. No, A is smaller.
A is smaller. So, B is your big figure. So, they give us A and they want us to find B. So, if I'm going A to B, am I enlarging or shrinking?
Enlarging.
Enlarging. I'm going from small to big, so I need to multiply. So, we start with 23. What am I multiplying by? 2.5.
2.5.
That's my scale factor. Do I need to square this or cube this?
No.
No, it's just perimeter. So 23 times 2.5?
57.5.
57.5 inches. Okay, so you need to, 1, understand whether you're going to multiply or divide. Then you need to, 2, understand, do I need to just multiply it by the number, multiply it by it squared, or by it cubed? So B, they tell me the area of B is 45 inches squared. They want us to find the area of A. Am I going small to big or big to small?
Big to small.
Big to small. I'm going from B to A, so I'm going big to small. So I need to
5.
divide. Okay, so 45 divided by, my scale factor still hasn't changed, so it's 2.5. Do I need to do anything to 2.5?
Square.
It needs to be squared, its area.
7.2.
Oh, wait.
Let me grab my answer key. All right, I pulled my answer key. Now, where did I put my answer key?
Trust me, it's 7.2.
7.2?
7.2.
Oh, did I set it right there?
I think about you go.
No wonder he's so smart up here. He's got my answer key sitting on his desk.
He said he broke his glasses.
He said he broke his glasses. What'd you do that for? Why are you wearing your glasses in bed?
Nah, it's because I was on the phone and I hung up my glasses off because I'm about to play some video games. The controller's over there on the ground.
And you went to reach for it and fell because it was
Yeah.
too far?
That's the worst way to go out.
I'm sorry, I shouldn't laugh about that, but that's funny. Okay, so we're talking C and D. Which one is my big figure? Which one is my small figure between C and D? D is my big. Okay, D is my big, C is my small. So I start with D and I'm going to C. So what do I need to do? Multiply or divide?
Divide.
We're going to divide. I'm going big to small. So 54 divided by
3.
3. Do I need to do anything with 3?
No.
No, we're talking perimeter.
You say 18.
18 inches. Okay. Part B. This time I'm going from C to D. So I need to do what?
Times 3.
Multiply.
Times 3 squared.
Good. I'm talking area, so I need to square 3.
315.
And it was just a calculator. 54 times 3 squared.
Uh-huh.
I got 486. I got you.
Yeah, it is 486.
Look at you.
Alright.
I got 486.
Ain't no way.
Hold up.
Oh, because that should be 35.
Yeah, that's what I was looking at.
Never mind. Listen,
Yeah.
I need to go home just as much as y'all do right now.
Right.
I
still got that hangover.
Wait, I typed
Right.
That time.
I didn't put in 35.
Look, I feel slow. Alright.
Sorry, that was my bad. Trey, what you entered was correct. And if it would have been 54,
Right.
your answer would have been wonderful.
Sure.
Oh, you put in 54.
Okay. Another thing you're going to have to do in this section is you're going to need to solve for unknown variables. Okay. So in order to do that, you're going to have to set up a proportion. So if they tell you R is a rectangle that has a length of X and a width of 4. R prime is a rectangle with a length of 10 plus X and a width of 9. Find the value of X. So we're talking length and width. So that's what we're going to use for our ratio. Length over width. So for the first rectangle, if I want to make a fraction that's length over width, it's going to look like what? X over 4. So if this one is length on top, width on bottom, the second one also has to be length on top, width on bottom. So what goes on top for the second fraction?
10 plus X.
10 plus X over 9.
Cross multiply?
Cross multiply.
Right.
So 9 and X
9x.
and 4 times 10 plus X.
40.
Plus
48
4x.
plus 4X.
Okay. You can skip this step if you want, if you're good with just 4 times 10 and 4 times X. If you need to see this step so you don't mess it up, write it in.
It's 40 plus 4x, right?
Yes. So it comes out to be 40 plus 4X.
And you subtract 4X.
Okay. So Marcus said I need to subtract 4X from both sides to make my X's go to one side. I'm left with 5X equals 40.
X equals.
Right.
We divide by 5 and X equals 8.
Do we have to three all over negations then, or are we just good with just finding the variables?
All it says in this one is determine the value of x that makes r and r prime similar. So you are good to go.
Right.
Because I taught it in math too. We're getting ready to cover this on Friday with my math 2 class. Okay. Two triangles are known to be similar. One triangle has sides of 3, 4, and 5. It's only known that the middle side length of similar triangle is 14.4. We need to find the other two sides of the triangle.
Okay, I know.
Okay, so I've got one triangle with sides 3, 4, and 5. All I know about that other triangle is I have a middle that's 14.4. What number does that go under? The 4. That's my middle number of the first one. So this is unknown and this is unknown. So we're going to break this apart and create two different proportions. One that's going to solve for x and one that's going to solve for y. So the proportion that's going to solve for x is the one with the numbers and the one with the x. So we cross multiply. X times 4 is 4x. And 3 times 14.4 is what?
What is it? What is it?
What did we get?
43.2.
43.2. Okay, divide by 4.
10.8.
So that's the small side.
What's the small size?
10.8.
Oh.
Because that's underneath the 3, so that makes this the small side. Okay, then we've got to solve for y. So again, the fraction that has no variables and the one that we're trying to find. So we get 4y equals 5 times 14.4, which is what?
72.
72 even. Okay, divided by 4,
18.
y equals 18. So its longest side is 18.
We should just like stop and do the homework. Right.
You're going to be okay with the next two. It's when we get into this last little chunk here that you're going to be like, what in the world? Okay. This time we're talking about rings. Okay. If you need the picture, draw a picture. Okay. It's fine. So it says O and O prime are similar rings. The inner radius of O, okay, when they're talking inner radius, they're talking from the center of the circle to that first little circle. That's your inner radius. It's the inside circle. And that is a 6. The inner radius of this one is a 12.
Well, that's easy. Right.
So what's my scale here? What's
Times
happening?
2.
Times 2. Okay? So then they tell me that the outer radius of this one, so that's from the middle clear to the outside, is 24. They don't tell us what this one is, though.
12.
But it's 12 because it's times 2. Fantastic. Okay, now, this is why I said, what is the formula for the area of a circle? What is the area of the ring of O? So all they want is the area of this shaded region.
Ooh.
Well, that's
Ooh.
easy. You just gotta figure out the area of both of them,
Yay.
and then you subtract the area of the
Hold
middle
up,
one.
hold up. Listen to Andy for a minute. Go again.
So you find the area of both of the circles, and then subtract the one by the one in the middle.
Good. Okay, so if you had, let's say I had this rectangle here, okay? And this rectangle is 5 by 4. So what's the area of my rectangle?
20.
It's 20.
20.
Let's say I go through and I cut out this piece that is 2 by 3. What's the area of this piece?
6.
6. Well, all I want is this area. So,
Just subtract.
you found the area of the big, you found the area of the small, so take it away.
14.
Which means my shaded
Yeah,
area
that's
is
my
14. You're going to do the same idea here. So, the area of the big circle. Remember, we said area
Pi r
is
squared.
pi r squared.
Wait,
So,
how
Now
do you
you
know
just-
which circle you working with? Because it say ring O.
it's a O,
So that's a small one.
so that's your small one.
113.04.
Okay. So, pi r squared, my big circle, my radius is a 12. I want you to leave this in terms of pi. So what I mean by that is you're just going to square 12. What's 12 squared?
144.
So this is 144 pi. Okay, this is your big or your outer, however you want to denote it.
Let me select.
Okay, we need to do the inner. So this is 36 pi. The big one minus the little one gives me the shaded region.
Wow.
So my shaded region is
108 pi.
108 pi. The only way I ever want you to use a number for pi is if they tell you to use a number for pi.
So,
You can leave it in terms of pi if you want.
So the answer is 108 pi.
where'd you get 108?
You subtract 36. from
Subtract.
44.
Okay, that's
The
what I
two.
thought. All right.
How did it start you off?
Okay, never mind. I see it because of 12 and 6. Got that.
Right. I got the 12 from here because from the center to the outside circle, the radius is 12. And the inside circle is 6. So that's your radius of your inside and the radius of your outside.
So basically, you didn't use this.
Basically, I didn't do what?
Use the big circle.
This one? No, because they didn't want anything to do with this circle. All it was asking for was the area of ring O, which is this one. This one's O prime. Okay? Good question. Anybody else? We good?
Yeah, we're done. Let's go home.
I wish. An isosceles triangle has lengths of 14 and 18. The second isosceles triangle has side lengths of 63 and 77. Are these two triangles similar? Set up a proportion and find out.
Right.
So,
Easy. All right. I know what to do.
so we're creating a fraction of our first triangle. So 14 over 18. What should my second fraction look like then?
63, 70.
63 over 77. If this is small over large, that should be small over large. So now we cross multiply. What's 18 times 63?
A big number.
Huh?
Big number.
A big number.
1,134.
1,134
They're supposed to be equal, right?
equals. What's 14 times 77?
1,007.
Do they equal?
No.
No, so these are not similar.
I've been told you.
Please on your test, don't just write not similar. Like, I need you to actually do the math that shows it. Nice try.
Before you put it.
Okay, you need to prove that they are similar. All right, last thing we need to talk about,
More stuff.
gnomons. Okay, so when we're dealing with gnomons, you're gonna have all of these original figures. And these are your ones in white,
Goes to
okay?
original. What you said?
Yes, these are your original. So A is the original, if you need to write that.
Is it always gonna be like this?
Yes.
Okay.
Okay, so A is some figure. A gnomon is something that we cut and attach to that figure to make a similar figure. So when I cut this little backwards L shape out here, and I attach it to this, what that does is it makes me a bigger square that is similar to the original. Okay. I can add a little square here and it makes a rectangle that is similar to the original figure.
Is G just that outer layer?
Here,
Yeah, is that
Yes.
just that outside circle?
yes, this fits on the inside. Okay, so here I add this donut looking thing to the original circle to make it a bigger one, and my figures are similar. So we're gonna have to be able to solve problems like this. Make sure too that you're actually answering the question that they give you. So my question here is, what is the area of the shaded region? Well, first I need to find what?
The area of the figures.
I have no idea.
They're a rectangle.
The length and width.
Okay, the length and width of it. I don't know what X is. Okay, so this is my original figure. 9 by 36. So we're gonna make that our first
Oh,
fraction.
that's a number.
9 by 36.
Do we have done 36 over 9?
Yes. If you do 36 over 9, you just need to do the longer side over the shorter side. So I'll do it both ways. 36 over 9. Okay? Now, I've added onto my original figure, and now I've got this figure. This figure is what by what?
36.
36. What is this side though?
Who knows?
No, it's not X.
It's X plus 9. Okay?
Oh.
This section of it is 9, and we've added on this section, which is X. So this is 9 plus X or X plus 9. I don't care how you want to write it. That make sense?
So these aren't similar. Well, I mean, you know.
We're going to make them similar.
Oh, okay.
Okay? So, this one, I did short side over long side. What's my short side now?
36.
36. So this needs to be 36 over 9 plus X. Okay? When I added that extra piece, that made the short side of my rectangle my new long side. Okay? Or if you did it this way with big over small, this would be 9 plus X over 36. Either way, both of these are going to give you the same exact answer when you cross multiply. So, we cross multiply. This should become 9 times 9 plus X equals, what's 36 and 36?
1,296.
1,296.
1296.
Distribute your 9 through if you have not done so already. So 81 plus 9x equals 1,296. We then need to
Subtract 81.
subtract 81. So we get 9x equals 1215.
1215.
135. When you divide it by 9.
135. Yeah.
X equals 135. But I'm not done.
What's 35 plus?
Okay? X is now 135. So this is 135. What did you say this side was?
36.
36.
And we have to find the area.
So we need to find the area of this shaded region, which is now 135 by 36.
Are we not going to add?
Outside.
You gotta add the 9,
4,860.
right?
4,860.
Wait, don't you gotta add the 9?
Be careful. They only want the shaded region,
Oh.
which is just your X section.
I can't write in the black.
Okay? They only want that shaded region. Okay?
Oh.
If they wanted the area of the entire thing, then yes, you would have had to add 9 to 135 before you multiplied. Does that make sense?
Yeah.
Okay. Kind of, sort of.
I really think so.
This is the part of chapter 9 that everybody seems to struggle with.
I mean, I kind of get it. It's just weird, you know? Because it's like, it's making the same shape, right? It's making a similar shape, but it's like, you have to rotate it and stuff. You just gotta figure out which side goes where.
Uh-huh.
That's enough.
especially when you're dealing with triangles.
Yeah, especially when
Right, right.
you're trying to-
The rectangles are usually pretty easy to see. It's the triangles that suck.
Squares.
All right. So here we go again. Here's my original figure. So it's 3 sides. 6 is your small, 9 is your middle, 12 is your large.
Okay. 12 is what?
What do you mean?
Say that one more time.
6 is my small side of the original, 9 is my middle side, 12 is my long.
You
Is
did
it always
that.
gonna be in that order?
You did that based
So
on the-
smallest to largest or whatever? Like when you put it in proportions like that? Does it really matter?
No, it doesn't really matter what order you put it in. You just need to make sure when you're looking at the new figure, once you add the gnomon on, that you put the small side underneath the 6, the medium side underneath the 9, the
Yeah.
big side underneath the 12. So I could have switched up the order of this. My logic, I always go small, medium, large. That's just me. Okay, so now I've added this piece on and now I've got this big triangle here. What's my small side?
The
12.
Now that you done.
And then
Okay,
Y.
now that I've added this chunk on, 12 has now become my small side, so it goes under 6.
Then Y.
Okay, then Y is my middle side,
Then 6 plus 6.
and this side here, what has this little chunk of 6, and this X, so this is actually 6 plus X. Yes, sir?
Need to file for last school to start out.
Right.
Oh my goodness.
leave it up to homework.
Never.
Yeah,
There you are, friend. Okay, so I need to solve for X and for Y. It doesn't matter which one you do first. Again, though, when you solve for it, you need to add it with something that has no variable. So this fraction will be proportional to this. This fraction will also be proportional to this.
Y equals 18.
You always want to go back to the one that doesn't have a variable. So we're going to do 6 over 12 equals 9 over Y.
Y equals 18.
Y equals 18. I don't even need to cross multiply this. How do I go from 6 to 12?
What about 2?
Multiply by 2. So 9 to Y,
18.
18.
18.
Okay. The other one, however, is not quite as easy because it's 6 plus X. So 6 over 12 equals
Wait a second.
12 over 6 plus X.
That don't make no sense.
What?
So,
So you're
6
gonna
times 6 plus X,
Yeah, I got 36 plus 6x equals 144.
36.
And then I subtracted the 6, it's 108. And then divided it by 6. And it was
Okay, so you subtract 36, and you
108
said you got 6X equals 108.
divided by 6. It's 18.
Okay? That's okay.
How does that work? How can we have both of those 18?
But watch. This is 18, because that's Y.
Oh, right.
This is
right.
6 plus 18, which makes this side 24.
Okay.
Okay? So even though X and Y came out to be the same value, don't forget the X is with a plus 6. Yes, sir.
So when we figure those things out, you always, when you have the variable, you always have to do with a non-variable fraction. Like,
I would.
okay.
Now, they said last period, they were like, but we know what Y is. Why can't I do this? And I'm not saying that you can't. But what if you screwed up and got this one wrong? Then you set yourself up for failure because you already started with a wrong answer. So my suggestion to you is always go back to one that does not have a variable. Okay? But you can very well use the 18. It comes out to be the same. Okay? All right, here's this one. Find the value of X so that the shaded region is a gnomon to the white square that is 7 by 7. So they tell me that this is 7 by 7.
So, are we going to do 4 proportions?
This one's actually super easy. Okay, so this is 7 by 7. What is this square? How do I find this side?
Oh, you know what? You can just add the 6 and 5.
To the what?
7.
This side is 5 plus 7 plus 6, which makes it what?
A number.
18.
A number of 0.5.
So this is 18.
And that makes the other side 18.
Okay?
Yeah,
That
so
also
it'll be
makes
18.
this side 18. But hold up, they said find the value of x, so I need to find the value of x.
Oh, man.
Okay? So this side is actually x plus 7 plus 7.5. So this is x plus 14.5, which means x is what?
3.5.
This side is X plus 7 plus what? 7.5.
Just take your pencil, Natroya, and literally, as I cross and I get to this spot, this value is x. As I cross and get to this spot, this value is 7. As I cross and get to this spot, this value is 7.5.
So how did you just find X? Oh, you.
Because we know the entire thing is 18 because this is a square. So if this side's 18, that means this side's 18. So you would set this equal to 18. Subtract your 14 and a half and get 3 and a half. Okay? Anybody else lost, confused, need me to go over that again?
Nice talking.
I will gladly do it if you need it. Good? Trey? All right? You sure? Don't shake it if you're not. Okay. All right. So now it's saying, what is the area of the shaded region? Well, just like we did the thing with the ring. Okay? I first need to find the area of my big square. How do I find that?
18 times 18.
18 times 18. So what?
324.
324. I can also find the area of this square,
49.
which is the chunk I need to take out. 7 times 7 is 49. And finally, subtract the 2, and that leaves us with the outside edge that we want to find the area of.
275.
275. One more and I'm done. And you've got 45 minutes to work, friends. Okay, here's my last one. Again, my original figure is a 5, 12, 13. So I always put it in order. 5, 12, 13.
I think it's times 2 again. You know, those 2 5s, and that's the same size. That goes under 5.
Everything.
That will help with everything but why.
Because you have to do 13 plus 1.
Okay, so small, middle, long. What's my small side on my big figure though? Once I've added my gnomon, what's my small side now? 10. It's this side here, which is 10, because it's 5 from the original and 5 from the gnomon that we added on. What is my middle side?
X.
X.
Yeah.
What's my long side?
13. I mean,
13
13 plus what?
plus what?
Yeah.
Louis, I'm so proud.
I still don't get it.
Oh my.
That's the only part I know. Try to put it in.
Okay, so again, when we want to do our proportions, always pair it with something with no variable. So 5 over 10 equals 12 over x. Again, this one's super simple. To go from 5 to 10, we times 2. So 12 to, which gives me,
24.
okay, so there's one. And again, this one, go back and pair it with the one that has no variable. So 5 over 10 equals 13 over 13 plus y.
Y equals 13.
So it's 130 equals,
65 plus 5y.
subtract your 65 from both sides,
65.
equals 5y, divide by 5. And you said y is 13?
Yep.
Yeah.
Okay? Again, it's asking though, what is the area of the shaded region?
That's 12.
What's the area for a triangle?
Is it a squared plus b? That's what that.
Pythagorean
Isn't there
theorem.
some like
That's not
x
y.
plus y plus over divided by 2, something like that?
Wait, what'd you
Yeah,
say?
that's it. X times y divided by 2.
Base times height. Divided by 2.
Yeah, something like that.
What is
Yeah,
it?
I was.
1/2
Times-
length
Times
times height.
times
Or-
height.
Length times width times, length times width times height.
Okay. So we need to get the area of this big triangle.
What's that?
What is x? 24. So the area of the big triangle is 1/2 times 10 times 24.
I got no.
So what's 10 times 24?
Oh,
I got you.
224.
I thought we were only finding the area of the
Depends on
shaded
what?
region.
I
Why?
understand that, but it's the same thing where we have to do both and subtract.
240.
Oh,
How are you going to find the area of this? It's not a rectangle.
oh yeah.
No.
I got you.
Okay, so while I understand that we are only finding the area of the shaded region, this is just like the ring, just like the square. I've got to find the area of the big one and subtract off the area of the small one.
Yeah.
So the area of my big one comes out to be 120, correct? Okay, the area of my small one is 1/2 times 5 times 12.
30.
Okay, your height was 5, your length was 12. You said this was 30.
Yeah.
So if my big one's 120, my little one's 30,
90.
that means the shaded region is 90.
What's the equation of length times width times height divided by 2?
Length times width times height is volume of a cube or a rectangle or
Don't turn it.
a rectangular prism. Thank you.
The area. Is that second part the area that was
Of the little white piece, yes.
You tell me.
Okay. Are there any questions?
I just remember my formula.
I'm trying to think if there's any